In this video, we're going to talk about 2.1 Objective 3, where we determine the level of measurement. What do we mean by data at the nominal, ordinal, interval, and ratio levels of measurement? So let's choose the correct description of the nominal level of measurement. The nominal level of measurement is characterized by data that consists of names, labels, or categories only. The data are qualitative and cannot be ranked or ordered. So that's A. Choose the correct description of the ordinal level of measurement below. The ordinal level of measurement applies to qualitative data that can be arranged in some order, such as low to high. In general, it does not make sense to do computations with data at the ordinal level of measurement. So that's D. The only thing that we would want to do sometimes with ordinal data is say how many places above or below in ranking did someone finish, something like that. But that doesn't really give us much meaningful data. Choose the correct description of the interval level of measurement. The interval level of measurement applies to quantitative data for which intervals, meaning that you can do subtraction, are meaningful, but ratios, meaning division, are not. Data at this level have an arbitrary 0 point, meaning that 0 does not absolutely mean 0, nothing, like when we have 0 Kelvin, that's absolute 0, which means 0 heat, but 0 Celsius and 0 Fahrenheit don't mean 0 heat. So that would be a difference between a true 0, which we're going to see with ratio, and a arbitrary 0 that we see, like choose 0 to be the freezing point of water on the Celsius scale, for instance. All right, choose the correct description of the ratio level of measurement below. The ratio level of measurement applies to quantitative data for which both intervals and ratios are meaningful, and data at this level have a true 0 point. And I just described that with temperature. The Kelvin scale would be ratio, but Celsius and Fahrenheit, which we use more typically, are interval, but not ratio. We'll probably get to examples where that comes up. Determine whether the given data are at the interval or ratio level of measurement and explain your answer. Well, there we go. The first thing here is temperature on the Fahrenheit scale and its interval, because it doesn't have a true 0. So that's A. It has an arbitrary 0 point. Distances between your home and various places you want to visit. So that would be ratio, which is B, because you have a true 0 that you could go nowhere and stay at home, and that would make sense. And also you could say things like it's twice as far or half as far, and those things make sense. So for the data described below, identify the level of measurement as nominal, ordinal, interval, or ratio. A music critic's review scale: must listen, good, fair, bad, horrible. So this is something that we could probably rank here from low to high. So that would be ordinal, even though we haven't given it numeric values, on a scale of 0 to 10 or 0 to 5 or 1 to 10 or 1 to 5 or whatever. We could put those in order. We could assign them such values if we wanted to, because we understand which one of those words is better or worse than the other words. Determine which of the 4 levels of measurement is most appropriate here. Years in which US presidents were inaugurated. So that would be an interval level of measurement is most appropriate. B. And it's because the data can be ordered and differences can be found and meaningful, and there's no natural starting point. There is a time and space in history where we call zero, but that zero does not mean zero time, right? So we would have to use a completely different scale for time if we wanted to know that, and we really don't have a good accurate measurement for that because no one knows exactly right now when the beginning of time was. So that's why we don't have a true 0 point. For the data described below, identify the level of measurement as rational, ordinal, interval, or ratio. The departments of a supermarket that products are stocked in, such as produce, dairy, etc. So that would be something that is nominal. I don't think we really need to explain that those are labels that are categories and characteristics. For the data described below, identify the level of measurement, the weights of lab mice. And so that would be ratio. It's not just their differences that are interesting to us, but we could say that one is this percentage more or less, or twice as much or half as much. You get the idea that, and there is a meaningful zero, that 0 pounds or ounces or whatever is actually a quantity that's meaningful and is a true 0. Determine which of the 4 levels of measurement are most appropriate. Below, years in which the Olympics were held for the same reason that the years for the presidents were. This is interval, but not ratio. So that's B, because the way that we count years with the calendar, 0 is not a true 0. Determine the following statement and see which level of measurement best applies. A movie with a 4-star rating is twice as good as one with a 2-star rating. So that would be ratio does not apply. So determine if the following statement represents a meaningful ratio. Yeah, okay. So someone thinks that a 4-star rating means that it's twice as good as a 2-star rating, and they're wrong. So because that's not what the stars mean. So they're just like on a more like ordinal data and stuff like that, where you get it bad, good, average, very good, like so, like that, and it doesn't translate into like 4 stars is twice as good as 2 stars. All right, determine whether the given statement represents a meaningful ratio so that the ratio level of measurement applies, and explain why. One subject has an SAT score of 1800 and another subject has an SAT score of 900. So the first subject is twice as apt as the second subject. No, it does not apply because the measurement of the SAT score has an arbitrary 0 point. So that's A. You may not have known that about SATs, but That's their 0 score does not mean that it's 0. It'll determine whether the given statement represents a meaningful ratio so that the ratio level of measurement applies. Using carbon dating, one sculpture is found to be 1,600 years old, while a second sculpture is found to be 800 years old. So the first sculpture is twice as old as the second. Yeah, that makes sense because the measurement of age does have a 0 point, so that's A. All right, I think that's it for this video. So we'll come back next time and talk about 2.1 Objective 4. See you for the next video.